Humans, how are you? Today we're going to talk long division of polynomials. So much fun. Here's the deal. We use the division to figure out the zeros of one of these things. So like before we used the quadratic formula or factoring, so you would factor in and get like x minus 3 times x plus 4 equals 0, and you would say, oh, well, x minus 3, so x equals positive 3, that would be a 0, and x plus 4, x would equal negative 4, that would be a 0. We're looking for zeros. So in order to do that, you can do long division. And if it comes out where there's no remainder, then whatever you're dividing by becomes a 0. You'll see what I mean here in a moment's time. All right, so these are the values of the x-intercept on the graph. It's the x value when y equals 0, aka the intercept. There we go. So it has to have no remainder for it to be a 0. Now it's fine if there is a remainder, that just means it's not a 0, but we can still do division. So you did this way back in the day. You had 675 divided by 21, and we used long division back in the day, and it was not that bad. So you put the 21 here, put the 675 here, and then you're like, oh, 21 doesn't go into 6, so then you bring in the next thing. 67, you can get that in there 3 times. So 3 times 1 is 3, 3 times 2 is 6, and then remember you subtracted that from up above. So 67 minus 63 was 4. And then you bring down the next digit, the 5. How many 21s can go into 45? 2. 2 times 21 gives us 42. And we subtract it, which gives us 3. Now this would have been the remainder in 4th grade. But now we're going to put this number over what we're dividing by. We're dividing by 21. So it'd be 32 and 3 21sts. But you can simplify 3 over 21 and be 1/7. So it would come out to 32 and 1/7. So that's the idea here. So this would be the remainder, but we're going to put it over whatever we're dividing by, including when we get to these nastier problems. So let's try another one together. This is more of what we're looking at. So let me move over here. We're doing 6x squared plus 7x plus 2 divided by 2x plus 1. So we put the 2x plus 1 over here. We write this stuff inside the division symbol. Now you have to write it in standard form. And if we were missing something, like if we had no x's there, you still have to write plus 0x for now. And that doesn't happen on this one. So 6x squared plus 7x plus 2. Now we're taking it one term at a time. Look at the 2x. 2x times what would give us 6x squared? And we would say that's 3x. So we're going to multiply both of these terms by 3x. 3x times 2x is 6x squared. 3x times 1 is 3x. But just like with long division back in the day, we're going to subtract it. So we need to make both of these the opposite. So we'll make a negative 6x and negative 3x. Now 6x squared minus 6x squared, 0. 7x minus 3x is 4x. And just like the old long division, you bring down your next term, plus 2. 2x plus 1 into 4x plus 2. Look at 2x and 4x. 2x goes into 4x 2 times. So we do plus 2. 2 times 2x is 4x. 2 times 1 is 2. We have to subtract these, so we make them the opposite. 4x minus 4x is 0. 2 minus 2 is 0. So it worked out perfect. So that would be our final answer, the 3x plus 2. There is no remainder. We're going to get into some nasty ones now.